In this video, we're going to talk about how to use our student class to actually achieve something in a project. So we've created our student class. You probably remember that from the previous video where we defined the data fields or members of the class. And we also included some methods that are part of the class. Kind of a last step in our class would be to include comments for each of the methods that are part of the class. And we would want to do that with Java doc style comments so that it has the potential to generate that automatic documentation for us that easily matches the documentation style of the Java API. So remember, Java doc comments, you always start with /*, and then if you hit enter and you've already written the method, it'll fill in some of the information for you. And then it just expects you to fill in information about like a one-liner, what's the purpose of this method, and then also a description of any parameters or return values. So for each of these setter methods, I might put a summary in like assigns the student's first name. And then first is the name to assign. And we do something similar for all of them. So the set last name that assigns the student's last name, and last is the name to assign. GPA, that's going to assign the student's GPA, and GPA is the GPA value to assign. And then finally, our set credits that will assign the students completed credit hours, and credits is the credit hours to assign. Super. So now we have a documented class. That's nice. Whenever you're writing a project, it's important to include all of the individual Java doc comments for the methods that are part of classes that you write. If you're turning in something for like a lab or you're just messing around for yourself, then it's okay to leave the comments out. But anything that you're going to share with somebody else, like a project, you would want to include the documentation. So at this point, we have this finished student type, and now we want to be able to use that to do something. Now note that just making the student type isn't going to make our main program do anything. If we say we want to compile this project, let's do that. It says cool, everything compiled, and that includes the main and the student type whenever you compile your project. And now when we say we want to run it, nothing happened. It just says finished with exit code 0. And that's because our main program doesn't do anything, right? There's no instructional statements in here in main. So recall that just having a class doesn't make anything happen. Now we have to instantiate it, create variables from that data type, and then call methods to trigger activity. So let's look at how we would do that in a project. So at this point, we're not writing the student file. We've already finished that. Now we're writing the main file. And one of the first things we need to do is declare a variable of type student. So I'm going to say student. Right, it's called student type in my project. In the notes, it's just called student. But I called mine student type here, so it needs it to be student type to match with my code. So student type, did I call it something specific in here? Student 1, excellent, we'll do the same thing. Student type, student 1 equals new student type. So that line there is the instantiation of the student class. Instantiation is just a fancy word that means we created a variable of type student type. So we created a variable whose data type is defined by our class. We call that instantiation. And that's cool. But now we need to like do something with that. So remember, just creating the student object isn't going to do anything in our program. If we just run it now, it's still just going to say process finished with exit code 0, because it's just like defining int I in our program. Like that doesn't do anything. We have to like write some code that does something with that variable. So what can we do with this variable? Well, we could call the methods that are part of the class. And remember that we have 4 of them in here. We have one that sets the first name, one that sets the last name, one that sets the GPA, and one that sets the credits. And for each of those, we have to pass in information that means the information we want to store in that data type. So in my main program, I'm going to also declare 4 variables to store that same data so that I can read it in from the user. So I'm going to have string fn for first name, string ln for last name. I need a double for the GPA. I'll do it all caps. And then int for credits earned. Those are my 4 pieces of information that I need to know about a student in order to use those methods that we've created. Then I also need like a scanner in here, scanner std equals new scanner system.in, so that we can read data from standard input. So I'll need to import java.util. Cool. So now suppose that I want to read in some data. I need to do that in my main program, and I can include whatever kind of prompts I want. I'm going to say enter the first and last name of the student. And then I'm going to read in information into my first name and last name variable, stdin.next. And last name is stdin.next. And then I'm going to prompt for the GPA. And then read that in, GPA equals stdin.next int. And then I'm going to prompt for the credits earned. stdin.next. Oh, this one's the int, and then the GPA is the double. Gold star for you if you caught that. All right, cool. So I've read in all of my information here. Now note that just reading the data in here doesn't automatically connect it with the student type. So at this point, all I've done is create this empty student encapsulated object that doesn't store any information. And then I created 4 local variables, individual values not encapsulated together, and read in data from standard input into those individual local values. Now I need to transfer the information from these local values into this new bundled data type. And I do that through the student types method. So I'm going to need to use my setter methods that I created to make that happen. So let me call one of the setter methods. I want to call the set first name method. So I'm going to use my object name here, student1. Typing trouble. Student1 dot, and then I'm going to call my method set first name. And then I need to pass in a string that represents the person's first name. It even like pops up and tells me what I should enter there. So I'm going to use my local variable fn because that represents the first name. Super. Now to add in the student's last name, I need to call the set last name method. And again, it'll pop up and tell me that's the last name that I'm supposed to put in there. So ln. Then I want to call the set GPA method. And I'm supposed to put the double that represents their GPA in there in this program that's called GPA all caps. And then finally, my last piece of data to set It's telling me that doesn't exist. How did I capitalize it in the other file? Set GPA, set credit. No, yes. And so I need to pass my credits earned in there. Credits earned. And it probably seems pretty obvious, but these variables that we have locally, FN, LN, GPA, and credits earned, those don't have to match the variable names that are in my class at all. And if you think about it, that makes sense. Like when you're trying to store information into a string or something, you don't have to like guess how the people who wrote the API named things. That would be crazy. So those two different pieces of the project are completely separate from each other. You don't have to duplicate identifiers across the two files. In fact, a lot of times it's less confusing to me if they're named something different that just like emphasizes in my mind that these are two different scopes, two different pieces of code that are playing together, but not identical. Let's see if there was anything else that I had in the notes here that we should be including in this particular file. So I had my local variables, I read the data in, I made my student object, and then I stored all the information in it. That's cool. And I just wanted to emphasize the fact that we can also, we can also make other variables. We're not limited to just making one student in our class or in our project. We could create lots of variables of type student type. So we could have another student type. Student 2. And the student's data would be completely separate. It's a whole other object separate from student number 1. And so we could read in information about it as well. I'm going to just recycle all my code that reads in the data. And then to assign those new values to student 2, I would say something like student 2 equals, or actually I didn't do like, oh, I just used literals in the example in the notes. I'll do that. So if I want to say student2.set first name, and I want the first name to be Joe, I just store that in there. You can do that. You can have literal values as your argument for your methods. And then student2.set last name, Smith, student2.set GPA, sorry, spelling, GPA, I want 3.25. And then student2.set credit, and then 15. Cool. I use Jones in the notes with that. So that would create a second object of our student class, student 2. I'll do another video in a second where I can draw on a whiteboard and show kind of like what's happening in this program as we're setting up these data values.